Okay, Math 9s, welcome back. In this section we'll look at Chapter 2.4, which is the Exponent Laws Part 1. Okay, so our focus for this chapter will be to understand and apply the exponent laws for products and quotients of powers. Okay, so products and quotients of powers. So first of all, what does product and quotient mean? Product is just the multiplication. And quotients is, when we're talking about quotients, we're talking about division. Okay, so the first one that we'll look at is product of powers. So product of powers is one big one. So if we have two powers that are multiplied like so, we can write those out as repeated multiplication. Again, a reminder that exponents are just a shortcut for repeated multiplication. So now if we have 5 times itself, here we have in the repeated multiplication column, we have 5 times itself 6 times. So that's going to be 5 to the power of 6. I'm going to start to see a pattern here. If I give you another one like 3 to the power of 1 times 3 to the power of 1, well, that's just going to be 3 times 3, which is 3 to the power of 2. Okay, and we'll start to see a correlation between these exponents here. 1 and 1, 2. Last one, if we look at 4 to the power of 3 times 4 to the power of 2, that's 4 times 4 times 4, that's 4 cubed, and we multiply that by 4 squared. That's going to be, if we add those all up, we have 4 times itself 5 times. And we notice another correlation here between the 3, the 2, and the 5. So with each of these things, the big idea here is, hey, if your base is the same, and in each of these lines, our base with each product is the same. So our exponent law for product of a power is if bases are the same, we can add the exponents. Okay, and if I use some variables to show that, if you have some number to the power of m times another number with the same base to the power of n, we can simplify that and just say that's going to be x to the power of m plus n. Okay, so that's the exponent law for the product of a power. Okay, so in a similar fashion, to do the quotient of powers, we'll look at the similar type of thing where you have, hey, just a reminder that when you're writing dividing, we can write 5 to the power of 4 divided by 5 to the power of 2, or we can write that as 5 to the power of 4 over 5 to the power of 2. So when we actually write this out in repeated multiplication, what I'm going to do is I'm just going to cross off, or even think of it as dividing, like 5 divided by 5. Well, that's just 1. Here's another 5 divided by 5. That's just 1. So this answer, what we're left with, is going to be 5 to the power of 2. Okay, and we'll start to look for correlation between our exponents that we started with and the exponent that we end off with. Okay, so if we look at another one like 2 to the 5 divided by 2 to the 3, that'd be like, okay, well, let's put 2 to the 5 on top, and then 2 to the power of 3 on the bottom, which is 2 times 2 times 2. Then we can cancel out some 2's on the top and bottom. We're going to be left with 2 squared. Again, we're looking for this correlation between what we started with and where we ended off. Again, the last one we can look at is, hey, what if we had 3 to the 4 divided by 3 to the 4? Well, that's just 3 times itself 4 times over 3 times itself 4 times. Okay, so 3 divided by 3, 3 divided by 3, 3 divided by 3, 3 divided by 3. We're left with 3 to the power of 0, which, hey, we know from our first section that anything to the power of 0, or to the exponent 0, is going to be 1. Okay, so the exponent law for quotient of a power is going to be to say, hey, if the bases are the same, so if you have x the base divided by the same base to a different power, we can simplify that to be x to the m minus n. Okay, so we'll get lots of practice with simplifying exponents questions. Okay, so on the back side, just a few examples to look at. It's pretty common to see questions to ask us to write each expression as a single power and then evaluate. Okay, so as we go through these, we'll have to apply the different exponent laws and then use our calculator to actually evaluate what those numbers are going to be. Okay, so here if we have two powers that are being multiplied, the bases are the same, so we can add those exponents. So this would be 6 is the base, it stays the same, to the 5 plus 4, which is 9. And if you pump that in your calculator, you end up with 10,077,696. Okay. Question number 2, the bases are the same. This is a quotient of powers, so this is where our base stays the same, and then we subtract our exponents. So this becomes -9 is the base, and the power is 10 minus 6, or -9 to the power of 4. And we can plug in our calculator. We should get 6,561. Okay, moving on, number 3 and number 4. This is a product of powers, so our base is going to stay the same of -2. We're going to add the exponents. 4 plus 7 is 11. -2 to the power of 11 is 2048. And then if we're multiplying a negative number an odd number of times, that number should be negative. So the answer to this should be -2048. If you have questions about that negative, please ask. We'll cover that more in class. But yeah, with an odd exponent, if your base is negative, you're going to end up with a negative answer. Okay, number 4. Here we can look at our base is the same. It's 3. So with our exponents, we have 3 to the power of 2 times 3 to the power of 4. So we add those exponents. So it's 2 plus 4. And then we're dividing 3 to the power of 3. So that's subtracting 3. And sorry, that's a funny looking 4. I'm going to fix that. That should be 4. So this should be 3 to the power of 3, which is 27. Okay. So big idea from this section, there are 2 of them. If multiplying powers with the same base, you're going to add the exponents. Okay, the second big idea is that if you are dividing, powers with the same base, you're going to subtract exponents. Okay, the next section looks at a few more exponent laws, but this section will give us some practice with the first couple. Okay, so our assignment here will be page 76, 4, 5, 8, 10, and then a selection from number 13, A, C, E, and G. So that should get us started in class. Okay, come to class with any questions that you have, and we'll go from there. See you then.